All right, so I will be moderating this panel. I'm hoping it will be spicy. So that's up to you, four of you. So the organizers sent me some questions, and I originally was like, oh, I'm going to rewrite all of them. But they were excellent questions, so I'm using their questions because they were very thoughtful, and I think will hopefully lead to some meaningful discussions. Any of you can answer, so if you want to answer, just raise your hand. You also don't have to answer. I don't think all the questions need to be answered by all the panelists. Sometimes it makes sense, but it doesn't have to be the case. So we have until 5:30, or? Okay, so we have like 45 minutes. So what I'll do maybe is I'll have like 20, 25 minutes of the prepared questions. Then there's like 5-10 minutes of some lightning round questions. And then we'll open it up for questions from the audience. So the first question, and I can sort of guess who might want to answer this, but maybe they won't. What did the Atari benchmark fundamentally teach us about DeepRL, and what did it fail to teach us? And raise your hand if you want to answer.
Okay, it taught us that DeepRL is super brittle, that, you train a policy and it really only works on this one particular game, starting at this particular time frame, with the pixels in this particular place, and if you change the colors, move the pixels a few steps to the left or right, and so on, it's just like everything breaks down. And it teaches us that it basically, look, this is barely any better than a lookup table. You wanted it spicy, right?
Yeah.
So things may have changed. Please tell me how things have changed.
Yeah, I definitely agree things are brittle. That drives me nuts. That said, I feel like I came from a history where when I started in reinforcement learning, I tried to use neural nets. I couldn't get them to work. I abandoned it and did other things. And so I feel like if nothing else, what the DQM paper showed was like, actually, if you do enough tricks, we can kind of get nonlinear things to work. And that was just such a big mind blower. I feel like a lot of us were just stuck on all the theoretical issues. And I think there's still theoretical issues we still need to sort out. But at least it feels like maybe there's a path to kind of getting there. And at least now we can make it practical. So that's good too.
I maybe want to disagree with Julian or agree with Julian. I don't know which. I think like the brittleness that maybe that you're pointing out, I feel like, I mean, it's an out of distribution brittleness. And then saying like, hey, we trained it on this thing, and then I changed one thing about the game that you never saw in training, and then we're disappointed that you didn't generalize the way I as a human would generalize. So maybe we're seeing the DeepRL methods aren't very human-like as an example. But I do think there's another brittleness going on that's disappointing. I think what DQN what Atari taught me about deep learning was we can replace feature engineering with very careful hyperparameter tuning. And I don't know if that's a win or not. It is in the sense that I think feature tuning was we had to bring our intuitions about the game to come to play. We have to say, oh, it's important to know where Pitfall Harry's standing. It's important to know where the vine is. So we need to capture all those things. And now we have to replace it with, it's really important to get the step size right and the buffer size, the replay buffer, and the frequency that we do updates. And I can't tell whether that's an improvement or not because I have no intuitions about those things, but at least I don't need domain knowledge.
I can maybe briefly respond because in my talk this morning I did say I think feature engineering is still a big problem. We did a lot of it in GT Sophie. We were in state variable land though, and my hope is if we move to things that are more vision-like, we can kind of get rid of that and put more in the model architecture and algorithm designed around that expectation, and then we'll be good. But if it's like a brand new domain and you're like building features for it, the features you choose matter a lot still. So maybe there's a in between here between what we're saying.
I'll skip this one.
Actually, you can keep the microphone and you can pass it around.
Okay.
Okay. So on that, following up on that, what properties should modern video game benchmarks possess to replace or complement Atari today?
Yeah, sure. So I would say some important aspects we don't necessarily have in Atari, but would love to see more of are these ideas of having a much vaster space that you can explore, and not necessarily very direct feedback to, like not necessarily a very direct way to evaluate, right? So in Atari, it's very nice, right? And we managed to make a lot of progress because you have this reward function that you can optimize for, and we know this work, we can make this work really well by now, right? What we cannot really make work, or like I think we still have a lot to make progress on, are these kinds of like very, very long horizon tasks, right? So imagine going from some like tens or hundreds of steps to really like tens of thousands, right? Or hundreds of thousands of steps, and really having a very like high level goal, and then figuring out what are the things you need to learn to get to that high level goal, right? So I think maybe this represents it's like a slightly different problem setting that I guess I'm very interested in, and I think maybe it's a bit closer to how, let's say, like humans learn, right? So usually you may not necessarily even have a particular goal in mind, but or perhaps you might like know you're going to be tested on certain things, right, in school and so on, right? But you do have the full kind of like flexibility to decide maybe like what environments to learn from, or like what sources of knowledge to learn from, and that might be maybe like a very different formulation that could allow for much more sort of like open-ended learning, right, and eventually being much better at generalizing to new tasks, right, or like ability to quickly learn on new tasks. And maybe just to bring it back a bit more specifically, right, I think like specific things I would love to see in these kinds of environments are like stochasticity. I mean, of course, you can add some level of that in Atari, right? But would be nice to have like, let's say, like, much more stochasticity in these kinds of environments, partial observability in a more real sense. And like not necessarily a very clean reward that you can optimize for, at least like very sparse reward. Anything?
Sure. Yeah, I think for modern games, the thing they're adding is much more complex action spaces and much more complex dynamics. And that kind of goes into, we get these sometimes big worlds, or even in GT, there's hundreds of cars with different dynamics. And if you look at like modern game controllers, and you actually start to enumerate all the buttons and things you can do, it's kind of insane. Like I've done it a number of times for like the PlayStation 5 controller, and like, oh wait, I forgot it has motion sensing. Oh wait, it has a microphone. That is a control input for some of the games. And it's like, it's this wild space. And it's this mixture of discrete and continuous. I think there's actually an interesting question about whether anything we do is continuous. But setting that aside, we basically have these continuous inputs along with discrete inputs, and it's just this massive action space. So that's another thing, all these complex dynamics that come out of that, and the way you can interact with it is a big gain.
It depends so much on what you want to benchmark for. So yeah, it's like depending on your like for video games or for AI, for general AI, for like testing a particular algorithm and so on. But for what I am personally interested in most, it would be more like, okay, so can you play a new game you haven't seen before that is in a basically what the inputs and outputs look like, but you haven't seen this game. Now play it a few times as a human would. Could you be good at it like a human would? So that's a big generalization thing. Note that that's something you could actually study with Atari, but which people don't generally do study with Atari. But I mean, that's something we try to get at with a general video game AI competition, which basically, it only worked for search algorithms because it was in Java. Which is a great programming language. You should try it. Your LLM can write good Java for you. But anyway, it's so basically having this thing where like you can't fine-tune a particular game. You have to play a new game that you haven't seen before. That's what I would want to do. And maybe I should try creating a new one again. Or maybe I should stop now.
So I'm going to go rogue. I'm going to go rogue and ask a question that wasn't here, because what you just said made me think of something that I didn't mention in my talk. I don't know if you mentioned it in your talk, but I think part of the reason why Atari ended up being a great way to show this superhuman capability, and why they could take, aside from reward clipping and all this stuff. They could take the same type of network, the same network template, and train it on these different games, is that the input modality is the same across all of the games. And this is not how generally we work. So it's hard to take something trained on Atari and then put it, say, to GT Sophie, because the input is completely different. And I'm curious what your thoughts are in terms of games, because I was thinking, is there a continuum between like the Atari joystick or the mountain car, like left right, the type of sophisticated controls we have now, and like just the continual stream of inputs that we have as people, or even as robots maybe, and what your thoughts are on how video games fit within this framework, and if there's a point where if we want these generally capable agents, if we need to go beyond that. Or just to add something to that, I saw a video, can't remember who, had trained an agent there was a video camera looking at an Atari screen, and there was a robotic hand that moved the joystick. I thought that was super cool, because that's really what we should be aiming for, right? Sorry? Was it?
Yeah, so currently got the joystick around. This is something that we did at Key, right?
Oh, cool. Anyway, so back to the question. So what are your thoughts on the role of video games in terms of generalizing this input modality problem?
How do I want to answer this? I think you're right. I think that the Atari was powerful because they agreed on input modality. The thing I've been thinking about more recently is to imagine long-lived continual learning agents. And one thing Atari promotes is to think about dividing up games into like tasks. It promotes very much a task-like thinking, that like I will learn to do Montezuma's Revenge, I will learn to do Freeway. And one could make a continual Atari, but we will think about it as tasks. But I really want to think about agents as just being one long-lived stream of experience of things in the world being different and changing, and you having to respond to it. And that requires the modality to not change, right? Like, so I think that's super important. But it also, I worry that we're going to come to that with all these other things we've done, always thinking tasks are there, our goal is to find them. And I worry that isn't the way to think about this. I think NetHack is a great example of a very long domain for which, I don't know, did your task change while you played it? Or did it not change while you play it? No one really knows. And that's much closer, I think, to real problems that we need AI systems to replace. And I think this notion of task is a thing that I watch the community, I think, fixate on too much, and I would love to see environments try to get rid of that while keeping all the modalities.
Yeah.
Okay, I can say something if no one else will. So yeah, I think, as I mentioned, there's the complexity of the game controllers, and I think what that exposes is we need to do much better generalization around actions, because the space is so big, and I don't know exactly what that means. It could mean we definitely need more expressive policy distributions than just Gaussian distributions that are independent. That seems kind of insane to me. But as we get it bigger, I feel like we can start solving that problem, and then if you get a new input, maybe it's not so bad actually to generalize, because you've kind of learned how to actually make composition out of your inputs and how they affect the world. And so maybe it will lead to that, and just this making it more complex will eventually get us there. Not sure.
All right, let's go.
I suppose you're right. There's something interesting that goes against your point, Pablo, which is I suppose you could expect an Atari agent who's played some Atari to then go to the NES, right, the Nintendo Entertainment System, 6 years after Atari came out, but they have a directional D-pad. Is that a different? Well, and the screen is a different resolution. Is that a different thing or the same thing? Would we expect an agent to be able to do well because it's already played Atari games or not? And maybe it'd be cool if we could see an agent transfer modality.
Yeah.
Because there's a lot of similarity, but at the same time, I mean, you maybe have a way to get there, which is continual, like the continuous action Atari works for both D-pads and 2 buttons as much as it does for anyway. Okay, it's just random thought.
Okay. So this is somewhat related to some of the points that I was mentioning in my talk. And is superhuman play a meaningful target, not just for Atari, but in general? Maybe in NetHack. Or is it just a distraction from building agents that generalize and collaborate with humans?
My feeling is it's a great way to get attention and write papers. And even money, you're right, money has come from this too. I think you might be right that with your second point, I think it might be a distraction in the ultimate scientific progress, but I think we are all more than a scientist, so it is not surprising that we might seek out that attention, money, papers. I think that's a reality, that's going to be a thing that people do. I think we can also, as a community, I think this was a message that you didn't hear in my talk. I think we as a community can appreciate work that doesn't do that, but we have to put some effort into that because we know the other one is going to get a lot of attention.
I think taking it back to benchmark, there is such a thing as overfitting. And overfitting happens on so many levels, on the sort of, directly on the level of the model you're training, or on the level of you're overfitting hyperparameters, and there's overfitting your whole procedure. And one of the tasks of a good benchmark constructor is to make overfitting as hard as possible. I think of constructing benchmarks as kind of an adversarial game in itself, where you want to sort of guard against overfitting, because people will naturally do it.
Yeah, I think it really depends, like superhuman on what. Maybe it's the question, right? Maybe one way to understand the question is, just like improve numbers on particular games, right? So that could be one way, right? And then I agree with Michael, right? It really depends what the goal is there, right? So it could be useful for, like, if you have a particular goal in mind of just engineering a system that works really well, or you have a particular application, you've built this simulator that you really trust, really simulates your application very well, in which case maybe being superhuman, right, like is the goal, right? It would be amazing, and you can put in any kinds of inductive biases, right, or things that you want to put in to make that work. And that seems like a valid goal to me, right? Like I don't know, maybe you want to do that for controlling nuclear reactors or other things, right? So I think it really depends what the goal is, right? But then when we think about perhaps we might want to just build sort of like agents that can learn as well as humans do, right? So then maybe we can make them superhuman, right? So can then they learn a completely new game in a kind of superhuman way, right? Or like can they learn, if you give them lots of different new tasks, let's say at test time, after maybe some time of like learning or training on various things, can they learn them as quickly or even much more quickly than a human? And to me, that seems like a potentially way of posing the superhuman kind of like a task or like superhuman goal in an interesting way, and perhaps like a valuable way. And then of course when we think about games, I think there's like just so many notions, right? You can, and I think Michael, you had this in your talk, right, of how like humans have like very different goals when they play a game. I'm sure you're touching on this as well, right? So it's not or like rarely it is about only maximizing a score, right? It can be like, oh, I want to be the best I can be at, I don't know, exploring this space or doing all sorts of other tricks. In NetHack, we definitely see this a lot, right? So actually there are different modes of playing NetHack, right? And people come up with new ones over time, right? So they just like challenge themselves of, like doing as well as possible with, as like few actions or as many constraints as possible and all sorts of things. So I think that also seems valuable if that's the goal in a way.
I guess I think it's a goal, but not the only goal. Like if we never had AI systems that could beat humans at everything, I feel like we're not done. Actually, we haven't fully finished the problem. We should be able to eventually match and then exceed people, or there's still more work to do. But it's like not the only thing. Getting hyper focused on a particular task is not necessarily useful. There is lots of fruitful problems we need to work on that aren't just getting that superhuman score. I mean, in GT, we beat the best players, and then we promptly did not put those agents in the game because that wasn't fun. So I think for AI, it's a good kind of watermark. We should always be striving to make sure we can do everything people can do, or we haven't fully solved the AI problem, in my opinion. but there's just so much stuff we need to do along the way too. That shouldn't be your whole focus.
Yeah, and I guess to come back to the first question, originally the superhuman motivation was to this sort of proof of existence that we can do this thing, and neural networks can be this powerful and this expressive if done correctly. But I guess at some point it becomes less of a meaningful metric, at least for Atari. So how are we doing for time? Okay, maybe I'll ask one more question before asking the last long question. And this is related to some of the points you were making, Julian, in your talk earlier. How do we assess generalization in a meaningful way beyond held out levels or random seeds? And Mike, you were also mentioning this, that these, you should be able to play a Atari game, and then like we as humans can then move over to NES and play those well. Seems like a meaningful generalization, but the way we measure generalization in a lot of these environments and suites is very limited to the benchmark itself. And so what's the right way to be thinking about generalization in this space?
I think I have strong thoughts on this. I think a thing that I've seen very commonly would be something like, I don't know, I've done this too, so like I'm gonna critique things that I do. I've trained something up on freeway mode 0, and I run that policy on freeway mode 1, and it doesn't get any points. I think that's a terrible way to think about generalization. Mm-hmm. Freeway mode 0 never saw anything that's about to happen in freeway mode 1. None of that lack of transfer is surprising. The very act of, I think, myself as a human, if I were to play freeway mode 0 and then transition to freeway mode 1, is I actually immediately see that the observations are different. Mm-hmm. I learn immediately from that, but we just turned off all possible mm-hmm. learning on the system. So at the very least, can we let our systems learn when we do the transfer mm-hmm. and keep learning still happening rather than freezing the policy? I think that's like an absolute minimal thing we have to do. I don't think that changes the results, by the way. I think we still see that these things don't it's not like they'll 3-shot that if mm-hmm. if you allow learning to turn on, and they'll suddenly just discover, oh yeah, it's still basically the same thing in freeway. But I think we can at least set up an environment where things where we're not making it impossible for the agent. I think that latter one where the agent gets to continuously learn, we can now ask, well, how we should be able to learn much, much more quickly. In fact, maybe we should expect to be almost immediate, but not quite like actually immediate.
Yeah.
Maybe just something I really love that framing. Something I wanted to add, right? You also want to not forget, right, or regress on previous things, which is of course is something that happens when you do these continual learning things. So I also do wonder what's the right framing, right, or what's a right setup for this, right? You can also say. And again, maybe like the sequential. I'm also not a huge fan of the kind of like sequential learning thing that we do in continual learning necessarily, right? So like, oh, here's a task, you have this time to work on it, and now here's another task, right? It's quite unnatural, right? It's not quite how I think like humans learn, right? So I do wonder if something like that's much more in a way like maybe self-generated by the agent, right, or like self-directed in terms of like what are the things to learn from could be helpful here.
I just want to add one thing about catastrophic forgetting. I think even the way we do catastrophic forgetting and measure that is also weird. We ask the agent, while you're not even seeing that experience, do you still understand it? And I don't know how to do that with a human. At the very least, show it to them. Again, have the agent learn and then go back and ask, did you forget it, by actually having you, while learning still turned on, to do that experiment. And anyway, I think we just do weird things with our agents that feel very unnatural, and then we're surprised when they act very unnaturally.
So just to keep being spicy then, one I like to think about is are episodic tasks actually episodic? We don't train our agents actually, they revisit the state. And if you actually let your agent know you're going to be doing this, the optimal policy shifts, right? Because now it's well, there's exploration I can do during this episode, and then eventually I'll try again. So why are we so stuck on episodes?
Agreed. No episodes. No
Yeah.
tasks.
Yes, no episodes, no task, revolution. But sort of because we got to be spicy and we got to disagree a bit. I do think that we do these weird things to ourselves as humans. Like, you know, I play a bunch of 2D games. I've seen a lot of 2D games, and I see a new 2D game, and I'm keeping the input in modality the same. I kind of quickly figure out that, hey, I'm controlling this guy over here because I've seen a lot of 2D games, and oh, I press this button and this, like, you know, I have a general concept of it's shooting. Well, I should probably shoot these things over here and stuff like this. So I do think that is a meaningful measure. Like, maybe not zero shot, but like 2 episodes or something of a game, and then you should be decently good at it.
Maybe we don't disagree. I don't know. I do think, like, when you say that, you're not saying, I don't think you're saying that I see a 2D game I've never seen before, and my policy is set. Like,
Oh yeah, okay.
I will do, I like you said, I will discover I control this object. But notice how learning's still turned on, right? Like, it's not like I know if I see this image, I will press left. You show me another image, I press right. It's not like I'm asking my policy to be fixed. I get to interact.
Yeah.
And I think that's just not a thing. I'm not saying nobody does it. I'm sure you can find some examples of experiments where that's what they do, but it's not the common thing. And it's not the common thing for the reverse of that with forgetting as well too. The common thing is to ask, can you still do the task that you're not doing right now if I were to just suddenly parachute you into it, but I'm going to leave your brain neurons totally fixed. They can't change. Nothing about that just feels realistic to me, but that's what we ask things to do. But I do agree with you, like a few shots. Yeah, I think we can set that as a goal. I think that's doable. But also I think our algorithms don't do it. Like, I'm not saying they do it right now. Yeah.
Exactly. Standard reinforcement learning paradigms don't really.
Yeah.
Don't really.
Yeah.
So this, it's not exactly the question here, but it's quite related, and I want to continue on this point because I think it's important. So we've been talking about, maybe implicitly, sometimes explicitly, about inductive biases in these games, and how we build these games, and how we design agents for these games, and how we evaluate these games. Whether it's you turn off the policy, that's a very natural thing. How many shots you get to take before you learn the new environment. And in the context of the world we live in now with LLMs and this whole like in-context learning and that type of thing, where you can provide examples and the parameters themselves aren't changing. And if you think of the network as a policy, but it's the context that allows it to generalize well, and it's just because these things have been trained over so much data. And so what do you think the role of that advance, which I still find quite interesting and mysterious, the type of research that we're discussing here, which is more like RL agents evaluated and developed within this notion of games, how does that, the advances we're seeing in LLMs fit into that, and should they?
It doesn't have to be LLMs per se, but I think that's all great. I think it's basically, you know, we have so many brands of what this is. Is it Meta RL or something like that? But I do think it's really important to build agents that can also, in a sense, they're learning how to learn from their history of experiences. And that seems really important because I don't, I think there is no grand singular algorithm that will work everywhere. This is like a no free lunch theorem type thing. So building systems that kind of learn their environment, the space of things they're dealing with, how to go from their history of observations to start adapting is great. And maybe that means it's a combination of generalized policy iteration and some other stuff, or maybe it's something completely and wildly new. That's okay too. Like we're interested in solving the RL problem, not using generalized policy iteration. So yeah, I think exploring that kind of stuff is cool.
Yeah, I guess in principle, I don't see any reason why we couldn't do something similar on, let's say, video games in particular, or some other kind of formulation where we have we decide on some kind of input-output space that's common and just train, you know, like train massive models or so on these kinds of trajectories, and we get some in-context learning. I don't think we've seen a real example of that. Maybe there's been some early work, right, or maybe on a smaller scale where there are some signs that you can the models can do some level of in-context learning. But yeah, in my opinion, that would be like really amazing to have, and I would love to see more work in that direction.
I agree.
All right, so maybe let's go on to the lightning rounds. So the rules here are you can only answer with one word or sentence.
Gonna be a very long sentence.
I'll have is there a buzzer? No. And then after that, we'll move on to audience questions. So prepare your questions. So first question, and maybe we'll go left to right for now, just to make it easy, and then I'll randomize a bit. Okay, so one game, modern or retro, you'd love to see as a new RL benchmark. It says NY, but let's keep the Y out, so that's really lightning. So one game that you'd love to see as a new RL benchmark.
Portal.
Sorry, I might have to pass on this. I'll let the experts chime.
Legend of Zelda: Tears of the Kingdom.
RimWorld.
What is it, like Dwarf Fortress?
All right, good answers. Okay, so maybe let's start with you,
Oh,
Jay.
okay.
And
Didn't do well
and you can choose what direction you want to go. No, it's just to randomize the order. Okay, a design decision from the Atari benchmark you'd change if you could go back in time.
I mean, I'd like to not have reward clipping.
That was not in the benchmark.
Yeah, so yeah.
Just because one organization did
Yeah,
something
okay.
silly.
I would have liked to have the benchmark then. And
But it's true.
yeah.
Somebody made a point, and I do find that the ALE and DQN get conflated a lot, and I'm sure that annoys you to no end.
Yeah, I think it's just hard because I don't have necessarily something better to offer at this moment. But there are lots of hacks that have happened maybe after it was very wisely put forth in the beginning. But yeah.
I would have definitely loved to have the setup of training on some tasks and holding out others. Was that in the original one, but not in the okay, not to be named one. Yeah, yeah. That would have. It was too hard maybe at the time, but then still it remained hard.
Fixed sort of like no kind of translation or changing of the pixels. No basically image post processing. I mean, obviously that's a tack on, but that would help to sort of
Again, also
shift
not
things.
in the benchmark.
Yeah, I know. Sorry.
Well, then this is definitely a question for you.
I mean, I would go with maybe. I think we should have periodically grabbed another 10 games and benchmarked algorithms over time. Every year, there's a new 10 random set of games added, and that.
A competition.
No. but I think we could have helped the community think about generalization in a way that we failed. We wanted them to do it by just following good practices, and they didn't do it, but we could have forced it by creating testing games periodically.
That's a great answer.
That was not one word.
No, it was one sentence. So there was one
Very long one.
Okay, what's maybe we can start with Roberta. What's more important for the next decade? Generality, performance, or deployability?
Generality.
Generality, as an AI researcher.
I'm having trouble parsing how to interpret these. I guess from my talk, I might say deployability. I want this to be easier to apply to things, but generality can also play into that. So
You can also pick another word if
Reliable, continual learning.
Okay, and the last one, and then we'll move on to audience questions. Maybe let's start with Julian. What research trend would you kill off if you had the power?
Framing things as leading towards AGI. Sorry, that was
No negative results. I'd love to see more papers on negative results or things.
I kind of want to say none to kill off. Like, I think part of the way research works is everyone has different ideas and they explore things. We probably put too many eggs in one basket, but I wouldn't kill things off. I'd let people explore.
James gave a very reasonable answer, and so I will then just lean into the question as if I'm forced to and say LLMs as agents.
Agentic systems?
The word agentic I hate so much.
I know. All right. Now let's go on to audience questions. So if you have a question, do we have another microphone? Okay. So.
What?
You could pass yours.
Oh yeah, I could actually. That's true.
Oh yeah, thanks.
All right. So you.
Actually, we can keep one here.
Yeah.
And
So
then
that one.
That's the one we know.
Awesome. So I'm more from the like procedural content generation side than the reinforcement learning side. So I was wondering, when you're thinking about benchmarks, do you think of benchmarks that are also good for PCG as well as RL? Like maybe something like Minecraft that might be good for both? Like, is that an important consideration as well?
I feel like this is a James question.
Sure. I like Minecraft. As an RL benchmark, I should add that. Actually, I don't play much Minecraft. But at Brown, myself and a bunch of people there actually started some of the early mods doing planning and reinforcement learning in Minecraft. So I do really like how open-ended it is and just how many things you can do in it. It's Turing complete. So kind of there's no bound except the memory and slowness and how big your computer that you make in the game has to be. So I do think that's really important. And I think moving towards these agents that can just kind of live in these giant worlds is a really interesting space. And if we're even in terms of applying it to modern games, there are a lot of very big world games these days, and so that's useful.
I think we should definitely have both, and I think really good benchmarks it would be great to have a modern benchmark that actually looked at both how well agents could play games in various styles, etc., and how well they could design games and game levels and game scenarios and so on. We tried doing that a little bit with GVGI, but Java. But someone should definitely do this with something that's more infrastructure friendly. And then basically you solve like the generalization problem as well, because basically then you have this nice kind of like arms race between agents that build games and agents that learn to play them.
I'm not really going to answer your question, but I think there's a lot to be gained from actually, if you've never looked at this literature, to go read about how people think about game design as an RL researcher, because clearly we're trying to figure out how to create environments that humans want to engage with and they want to play. And I think our agents are lacking severely. They're lacking play in how they behave. And if we could figure out how to get our agents to play, we would have much smarter agents.
I don't do video games, nor do I know much. But so maybe the question is off. But is the gold standard creating human-like AI? So I hear words like, oh, we should be able to generalize to this game, and it looks similar. But for instance, calculator, that's not human-like, and we love it. So is the gold standard human-like AI?
It really depends on who you are and what you want to do. So generally, I think in AI community, the goal standard tends to be beat the game, do it very well. And I mean, we've all been making fun of this. This is not the point, but this is what we can measure. In game development, people here may correct me, but I think the most common use case is to make something that is enjoyable and predictable, which has a decent overlap with human-like, but not only. So pure human likeness, there occasionally you see papers of this. I have worked a little bit on do things that basically pass Turing tests and so on, but it's not a major research direction. And perhaps it should be more of a research direction than it is currently.
Yeah, I mean, I largely agree with that. I think it just depends a lot on what you're trying to do in the game. Human-like is sometimes good. In GT, you want it to drive human-like because that's what people really want to be good competitors at racing. And so you want a practice partner for that. Or maybe you want something the gamer can learn from. And so some kind of humanness there is good. Or maybe you just want fun NPCs who do goofy things that humans wouldn't do, and then you really don't want human-like. So I think it just depends a lot on what you're doing in the game with it.
I'll add one more thing, which is there's the designers of these games, and very often they want to still have an artistic vision and they want control over it, and just throwing AI in there. An important aspect is it achieving the artistic vision of the design goals of the game. And I think it's important that there's an element that they want control within that framing of it's not still unpredictable.
Most games are made to not have AI.
What are some lessons learned from video games that we can apply to other domains, like for example for robotics, for benchmarking in robotics?
I think one thing, we talked about brittleness earlier. I think that many of the algorithms that we might want to apply to robotics, I think we can learn from within Atari games. And I think you gave some really great plots of we dissect this on individual games and we can see that whatever you set this hyperparameter to, I can find a game where that's the right thing to do. When we then do robotics research, we have to somehow take this into account better than we are. Very often we'll do hyperparameter tuning in a robotics problem almost as if it's an Atari problem. We'll just ignore the fact that I interacted with this robot and I tried a bazillion hyperparameters and I found the best ones, and then I'm going to show you how quickly it learns and just such a small amount of data, when in reality you have used 100x that data to figure out what hyperparameters to set it to. And in Atari, maybe it's okay to say we get away with that because it's so cheap to gather it, but that same story. We can't do the same things we do in Atari for robotics. And knowing how sensitive these systems are to hyperparameters, I don't know. There are people in this room who I know are working and thinking hard about hyperparameters and how we should account for that when we do our research. But I think that's a big piece that I think Atari has showed us, and that is going to be a problem as we try to make systems that are going to work on real world things like robotic platforms.
Yeah, I think from my angle, I always have viewed that robotics keeps you honest, because it's very easy to delude yourself that your environment you've set up is actually meaningful. And robotics, it's just the real world. That's just how it is. And you have to tackle all these things that we then build in as I can just gloss over that in this simulation. In robotics, you can't. So robotics is great for that. And then I find modern games are kind of the one step removed from that gives you a little bit of nicety, I don't have to worry about my hardware breaking when it does something wrong. That just sucks. It's a time sucker. Games, though, still have a lot of the same complexity. Especially now, they have all these open world, all these complex dynamics. And so you can tackle things like the brittleness. You can think about, hey, do I actually have a policy or a method that learns quickly that can tackle all these different situations fast? And so I think games, especially modern games, they're so complex that they reveal how hard it is still to get our algorithms to do anything well.
You were talking about moving away from episodes, and I think this makes total sense in reality because we only have one episode to learn, but we also have other agents and parents and that take care of us. And I don't know, I think that maybe the RL community ignores a bit this multi-agent interaction and learning from agents and with agents. And I don't know, what do you think about this?
I think that's all super important. I did a bunch of work during my postdoc on agents learning from people. not just the single reward and they're on their own. And I think if you want to, ultimately, you want agents that are going to interact with people in some way. And that means learning or not. Could be learning from other agents too. There's maybe shortcuts if they're other agents because they can just like download things from each other. But I still think that interaction is just very important to the whole process. So.
So I want to ask the four of you. So far, we have been talking a lot about how can we have AI playing well in video games, even very complex ones like Gran Turismo. And all of it has been about how can we have competitive agents doing the role of humans. But my question now is that we now can have AI doing a lot of interesting experiences for us in games. So what will be for you the interesting experience you would like AI to enable in future games?
Yeah, maybe briefly. Yeah, I think something that would be truly open-ended and truly, right, like something that I think right now all the games, or like, you know, most of the games we're playing, maybe with a few exceptions, are still quite, let's say, like narrow in the types of the kind of like learning opportunities or experience opportunities that you can get, right? So for example, okay, maybe we have some more open-ended games like Minecraft and so on, but it's a bit singular, it's not very adaptive, right? So I think it's kind of like, so it'd be like really amazing to have, you know, this kind of like maybe multi-agent or like, you know, like agent human game where you get learning experience that are, you know, interesting, exciting, and so on over time, and they're really tailored to your own kind of like interest, experience, or like, you know, gameplay and so on. So I mean, it's very vague at this point, but I think maybe we are at the point where we can start imagining things that would look vastly different from current game experiences or current human AI interactions.
I would want the algorithm to keep designing the game with me, for me, based on how I play. You know, you play a game you really like and you kind of exhaust it. But you know, what if there's more? What if, you know, the game grows with you? I've had this idea for a long time. So I actually had like, I used to sit next to office back in Copenhagen in the office next to T.L. Taylor. She was a game sociologist, and she was like, "Oh, all games have a social context." And I was like, "No, shut up! I like to close the curtains and unplug the internet and play the games all by myself. Thank you." But you talk about it to people, no. But you know, you do. But I've had this dream for a long time. But what if a game that couldn't have a social context? It was only for you, and the more you played it, the more it was really only for you, and only you and the game would understand it, and no one else would understand it. This only makes sense on an artistic level, probably not on a commercial level or anything. But I would still like that to happen in some way. Maybe I'm going crazy.
I mentioned RimWorld as a game, but I didn't specify that I wanted the AI to play the player's role of RimWorld. Maybe I wanted the AI to play the director's role of RimWorld. This maybe only landed for 10% of you.
I guess for me, there's so many things I think we could do that's nice, but there's a style of game which is like systemic-driven games where there's just a bunch of game rules, and they're really good at capturing these immersive moments that go viral on the internet, where it's like, oh, look at this crazy thing you can actually do. Doing that with AI is hard right now because the AIs just aren't very competent. They don't do interesting things, and it's hard to engage with them in meaningful ways. There's I don't remember who wrote this, maybe you all know it, but there's like this Twitter thread from a game people are talking about how hard doors are in games because of all the complications that creates. And if we just had agents that were more intelligent, at least had the same kind of intuition we did about moving around the world, I think we get these much more interesting interactions, not just with the game physics and stuff like that, but also with the agents themselves.
So I'm a little bit of a wolf in sheep's clothing here because I do robotics as opposed to video games by and large, but recently I've been convinced to do video games again. So take this with maybe a little bit of thought. There's been a lot of talk of benchmarks, right? And if I think, okay, the ALE and DQN had this sort of TikTok effect, where there was a platform, and then they figured out, oh, here's a way to evaluate things, and DQN said progress is possible, and then there was a lot of progress there, right? But the, let's say, diaspora from that is maybe more limited, right? We don't really have substantially new benchmarks with substantially new generalization. Or maybe I'm just not paying attention. In the vision community, they have benchmarks, which have sort of progressively pushed us towards larger networks and other things, right? So MNIST and such. And I think one of the aspects of the benchmark is that it has this umbrella, or there's many other things which are improved when you improve on the benchmark, okay? And it's not clear to me where we fall in that space with video games and RL, right? So one aspect of making a benchmark would be to have follow-on effects that, oh, improving on this benchmark actually improves your performance on various other domains, various other ways that you would use the underlying techniques. When thinking of benchmarks for video games and RL, what are the follow-ons that you would hope to see?
I think maybe getting back to the original intention of AL, having a singular method that kind of works across a wide range of things, I think is really important. It's really important to me and a bunch of other people at Sony, because we're in the business of, yeah, we want to make this technology that we can just apply to games. And if it's like, well, it's just a ton of work every time you do it, it's just not it. So if we could build more, we can't release the game code for the games we're working on, but if there were more benchmarks that just had wide variety of really complex games and very different complex games, and we could show, yeah, here is a method that does it well, that would be a big win. So focusing the community on that kind of benchmark might work out.
I think what I would add, it is true that when you look at the different fields like vision, right, or even others, right, compared to what we're doing in RL, seems very different, right? It seems like even robotics, right? Robotics right now, I think, started to, look at this training on very large data sets, right, and having somewhat, some benchmarks they can evaluate on. So I do wonder if there is maybe some kind of scope in trying to do something similar here, right, where you pose the problem of sort of generalization, or let's say fast learning of some new games, completely new games at test time, but you do get a huge data or huge number of other games to learn from, right? And again, you can unify observation action space to some extent, and then try to go for that as opposed to trying to solve each particular game at once. I'm not sure why that's not happening as much. I feel there are maybe some attempts with some, but still very small scale, right? Some maybe some benchmarks, right, that took us relatively small number of games or tasks to train on and then evaluate on new ones, but nothing very large scale. I'd love to hear more thoughts on this kind of direction from others.
Well, thank you all for this panel. This question is kind of based off of James's comment on the PS5 controller. And as soon as you said that, I started thinking, my parents have never really cared about RL before or after I showed them the video of the Atari Breakout Superhuman. That's the only thing that they've ever cared about, because that's the thing that they can relate to. So it's a two-part question. Do you think that the popularity of the benchmark was also due to the marketing of the Atari games being so generalizable to as many people as possible? And the second part of the question is, what modern suite of games do you think could be as marketable as Atari for the next generation?
I would be very surprised if it had to do with the Atari as a well-known console. I think it was stopped being well-known. Like you might say your parents, this was well-known to your parents, but I actually think that this had much more of an impact to the field than it had outside to the general public. I mean, obviously, ChatGPT has had a much more impact to the general public. I don't really think Atari did. Sure, there was news stories, people talked about it, but I think it had much larger ramifications within the community. And for most of my students working on this, they had I had nostalgia. My students had very little nostalgia. So I don't think that was an important feature. I think it was no one had seen RL do something at that scale before, to do something at that. So it was always one-offs. And I think that was the important factor. No one had run an RL algorithm on 50 domains before. And that was just the default of what you had to do to participate in ALE. So I think that was the bigger factor than, okay, I will say something. It was visual. If you just were to run RL on 50 domains and you were to just show a graph, that wouldn't have had the same effect as let me show a video of my agent playing. So I think it was those two things. It was very visual. Now, did that help for the general public? Maybe a little bit, but I think it helped a lot for the researchers. And then I think the second one is just the sheer scope of what people were doing. I didn't answer your second part of your question, so I don't know the answer. I'll let them answer.
The second part, which games, modern games?
What should we do? What else should we do?
Obviously, the next ones are all Sony-developed games. They'll have the most resonance with people.
Are they open source?
No.
Only James can
Yeah. But I do think what Mike was saying about it being visual is really important. And so I think if it's visual and also easy to understand, that's the other thing Atari has going for it, is okay, maybe you never played Atari. I feel like games were still pretty nerdy back then. So, but you can still understand it, right? You can look at it and understand what's going on. And maybe the problem with a lot of modern games right now is oh God, there's a lot of systems involved and it can scare people off. But there are ones that are more easily understandable. So maybe if we're trying to find some that kind of captures the general public more, it might be, yeah, it's a game, so it's visual already by default, but also it's kind of easy for them to understand, even if they're not a gamer.
I just realized something. Yeah, a lot of the game, we've had AI agents do Dota and StarCraft. And as much as people were maybe impressed by StarCraft, no one could, I think, really watch. It might as well have been watching AlphaGo play AlphaGo. All you can do is react to the commentary going, apparently that was a good move. Unless you're a Go player, right? Unless you're a StarCraft player, you couldn't really react to it. If you want to give an answer, I think Rocket League. Rocket League is something that anyone can watch and appreciate and knows what's going on. If we could have superhuman AI at Rocket League that did just crazy things that some of the pro players can do, or invented a whole new way of playing that sometimes pro players come along and do, I think that would capture people's imagination again.
Or Minecraft.
Yes.
Or Minecraft. Minecraft would work because everybody knows Minecraft.
Yeah. Minecraft was on my tip of the time. It is the game that everybody's. Yes, it has this role at the moment. Yeah. I think continuing that. Not a game, but a kind of a meta set of game. Roblox with all their hobbies and all the kind of. I don't know if how many of you ever played a Roblox experience? Okay, you're too old, all of it. I mean, but if you have kids, they probably have. I mean, my kids are too young still, but yeah, it's so weird. It's out there, man. It's just but it has a huge cultural cachet. It also has a unified game engine. It has a unified set of inputs. No, because you need to be a Roblox to do it. Now, of course, we have this trend within the games industry where the mid-market is getting squeezed out, and there's only indies and big titles which keep going on for forever, where they want these games to sort of live for decades at least. And yeah, Roblox could do this. If it was in their interest to do it. I don't know that it is in their interest to do this. But other companies that have evergreen games that just keep going on forever, like King, for example, could also do these things. Sorry, I just stole it in front of you.
No.
You're going to say NetHack anyway.
Yeah, exactly.
Yeah, there's one more question.
Hi, so my background is actually in offline RL and applications to healthcare. I came here because this was very outside my box, and I figured I could learn a lot. And I am glad that I came because I did learn a lot. I know that gaming is used a lot. Gaming simulators like Atari is used a lot for benchmarks for offline RL. However, my question to you is, in terms of for pure gaming applications like developing better games, building better NPCs, better AIs, is there any utility of offline RL? For example, in games where maybe simulators are extra slow, or where you need to pre-train from human data because of exploration problems or whatnot.
Sorry, I'm holding it, so I'm just like, absolutely yes. As we said before, there is definitely far too little work on playing in particular playstyles. We have, there's imitation learning been used to this, and various tricks and sort of the long-standing, if we're in racing games here, sorry for mentioning competitors, but Forza's drive avatars have been around in various forms since 2005, I think. And they have been based on kind of imitation learning plus cheating, or sort of like that. But you could definitely have like a generic pre-trained RL agent that is then fine-tuned on the traces of a particular player, and there is a lot of research to be done in how to do this well and how to do this fast and so on in a way that could be deployable in actual games and so on. So much to do with that.
Yeah, I think offline RL does have a role. There's maybe some nuances to it, and so to start, if we're building the game, you don't want to build it assuming you've got tons and tons of player data, because when you're building the game, you don't. But we still can generate a lot of data. Like, we had a lot of runs of GT Sophie and all the other game projects we work on. There's a lot of historical experiments, and it'd be nice to just like, okay, let's take that, let's bootstrap if we can. Oftentimes, it doesn't work as well as just starting from scratch, and that's frustrating. But if we can get that to work, that seems pretty valuable. And one other thing I do like about offline RL is it kind of leans into the brittleness problem of what our current algorithms have, particularly off-policy algorithms have, where they just fall apart if you're not collecting data very actively. And they don't necessarily have to find the best policy because maybe it's just not supported in the data, but they shouldn't just like diverge to infinity. That's not acceptable. And so I like that it's trying to tackle that. The one extra caveat I'd add that I think would be good for the game industry, but maybe just in general, is I think too often the way people address that in offline RL is like, well, let's kind of make it closer to behavior cloning. I'm like, that feels bad, because then you're like hoping you have really good data already in there that you can build from. And so if you can get offline RL working where you're not doing that kind of thing, I think that's the right kind of algorithm that could have a lot of impact.
Thank you.
Once again, let's thank the speakers.